Okay, for this exercise, I have set my project to the Hobstein SSS Portrait Lighting project. In the scenes directory, I have already put the scanned head exp.ma in there, and in the source images folder, I've put all of the JPEG files that I downloaded from my courses. When I go to File Import, the default wants to go to the Data subdirectory, so I'm just going to go up to the main folder here and go into the Scenes folder. Down here it's looking for an FBX. I'm just going to change that to All Files. Is my scanned head exp.ma. Now, it may take a little while to import this. And the reason is that the jacket is a scanned file. It's incredibly dense, so we may have to wait a minute or two. So here's the file. And I've done a couple of things to this file. The first thing that I've done is scaled it up so that the general size of this is about 22 centimeters. And a normal human head is somewhere between 16 and maybe 20 centimeters to the top of it, from the bottom of the chin to the top of the hairline. And then I've added a little bit to go to the crest of the head. So this is essentially a full-scale human head, and it's going to have a bearing on the subsurface scattering shader when it comes to the overall scale attribute of that shader. So we'll see more of that as we get further on in the tutorial. And I've got this broken down into 4 different display layers. There's the head layer, and then there's another layer that has the eyebrows and the eyelashes. And these are really just some geometry here. It's not XGen or anything like that. It's just a little bit of geometry. Then there is the jacket. It's a scan file. It is what it is. It's very dense, and we're just going to use it the way that it is. So we have the head, we have the jacket, and we have the eyebrows and the eyelashes. Looking in the hypershade window, each one of these pieces of geometry has its own shader associated with it, and this is just a Maya Fong material here. For this exercise, I'm going to just go ahead and replace this because it's a little bit less confusing. So I'm going to create an Arnold standard surface, and so what I'm going to do is just go ahead and replace this shader. So I'm going to go ahead and select this head and right-click on the standard surface and assign that to the surface. I'm going to rename this AI head Arnold, and I'll just call this AI head SG, just so I can keep track of things. And then I'm going to create a number of 2D file textures. In my source images folder, I have a head color, and obviously this is just the color map for the head. The UVs have already been laid out. This would be the gloss, is the equivalent of the specular roughness map. This would be the normal map, and then the specular map, and then this is a translucency map, which I find has limited application here, but we're going to use it, and then we're going to compare it a little bit. But this is kind of where the subsurface scattering is going to be the most translucent. You can see that that's kind of right around the ears, so that can be a little bit useful. All right. So anyway, I have 1, 2, 3, 4, 5 different maps for the head. So what I'm going to do is create a file texture here, and then just to shortcut this, I'm going to select this file texture and go into my edit menu here and say duplicate with its connections to the network. And what that does is it reproduces this file texture node but it keeps its connection to the placement node, which is what associates it with the UVs. And that's kind of what I want to do. It's there's no need having a different placement node for each one of these file textures, since they all apply in the same way. So from here, I'm just going to hit the G key, which simply means redo the last operation, and then I'll hit it again, G. So now we have 4, and I'll hit it one more time, and that's going to give us 5. So we have 5 different file textures, each connected to the same placement node, and I'm going to just go ahead and rename these. So I'm going to call this one head color. So then for each of these file texture nodes, I'm just going to apply the correct JPEG image. So for the head color, I'll open up the head color. For the head specular, the same thing. The other thing is that for the head normal, you want to make sure that the color space is set to raw. So looking at the Arnold standard shader for the head, we're going to want the color of the head color, at least for now, is going to go on to the base color. And I'm going to leave everything else off for now. And I'm just going to go ahead and set the lights. So to set the lights, I'm just going to go ahead and create a standard Maya area light, which will also work in Arnold. They're essentially the same. So I'm going to go ahead and look through the selected and dolly out, and I'm going to place this light somewhere up above the head and maybe a little bit off to the left. We'll see how that works. I'm going to take this AI shader and select the head, right click on the shader and assign it. I should be able to see this by hitting the 6 key. Then I'm going to open up the Arnold render view and go ahead and do a render. So here we've begun rendering, and the overall render has taken about 4 seconds, and it comes out black. Clearly because we have not done anything with the lights. I'm going to go into the outliner and select my area light, and I like to set the intensity to 2 at least, because the exposure is an exponent, and even though the exponent will work with an intensity of 1, it doesn't really make a lot of sense to me to put an exponent on an intensity value of 1. It seems like that would not work out mathematically. So I'm going to just go ahead and increase this exposure. An exposure of 2 does nothing. An exposure of 3 is going to be twice the amount of light, and that still does nothing. So I'm going to jump up a little bit, and I'll go to like maybe a 6 and maybe a 10. You know, the exposure that you use here is dependent upon the distance of the light, because it has a decay there. So I can't tell you what to use. There's an exposure of 12. 13 is twice the amount of light. 14 is twice again. So now you can see that you have this very, very shiny specular head with a color map on it. So let's just take a look at what we've got. Looking in the attribute editor, Arnold map here, we have a weight of 1 on the specular, and that's what's giving us those really tight highlights. And we have a very low roughness, and so this is looking like a very shiny sort of ceramic head with a color map on it. So let's go back into the hypershade window, and we can take this specular map and take the out color and map that to the specular color, and we can take the alpha of the head gloss and map that to the specular roughness. And now you can see that we've got a much better specular here. We can play around with that a little bit more but at least that's going to give us the opportunity to adjust our lights a little bit better. So take my area light and I'm going to take that exposure up to about 15. Now that I've got the lights set reasonably well, I'm going to go ahead and connect all the rest of those maps. So the head normal, we need a normal map in there. Let's just pull these off to the side a little bit. Now I don't have my my creation menu over here, but that's okay. I can right click in here and click on create node, and that's going to bring that up as a floating window. So in the Arnold section under utility, and I can select an AI normal map. Color of the normal map and map that to the input of the normal map node, and then take the out value and map that to the normal camera. Couple things. First of all, under the head normal, that this file texture is set to raw, and then the AI normal map, let's just take a look at this. I'm going to dolly in very close here, and I'm going to take my area light and increase the exposure just a little bit for now. And I want to just make sure that my normal map is being read correctly. So in the normal map, I have it's already set to tangent space to read the tangent space normals, which I think is correct. And then I have some inversion options here. I'm going to just click on the invert Y, and I think I get a better look from the inverted Y. This has to do with whether or not you're looking at this via OpenGL or DirectX. These normal maps were exported from ZBrush, and sometimes the orientation of these normals is flipped. So when you're translating from ZBrush to Arnold, or ZBrush to RenderMan, or ZBrush to another renderer, you have to be aware of how those normals are being written on the XYZ as it relates to RGB. So I'm going to just keep a snapshot of this. I'm going to go ahead and undo the invert Y, and I'll keep a snapshot of that. So this is the one with no reversal of the normal maps, and this one is with the Y inverted. And I think the one with the Y inverted is probably a little bit better, so I'm going to hang on to that one. So now I want to start working on the subsurface scattering. And the very first thing that I need to make sure of is that the normals are going in the right direction. So I'm going to select my head and go into my my modeling tool set here, and under display polygons I want to look at my face normals. Okay, so they are facing out, and that's critical to doing a subsurface scattering shader. So so that's fine. So in order to see any kind of subsurface scattering, what I'm going to need is another light, and the light that I need is a backlight so that I can actually see what's going on behind these surfaces. So I'm going to create another area light, and I'm going to go to the panels and then look through selected, and this light I'm going to aim from the back. And what I really want, here's my original light right there, and what I really want is to see some light coming through this ear, and so forth. So let's take a look at what we've got. So one thing that I'm going to do here before I go any further is I'm going to go to my camera. I'll select the camera, and right now this is looking just a little bit distorted. It's looking as though I'm kind of dollied in very close with a wide angle lens. So I'm going to take my focal length and I'm going to change that to something more like maybe 60, and then I'll dolly out a little bit, and that's going to give me a little bit less distortion on the head. What I would recommend that you do is take this initial area light, which is illuminating the entire face, and I'm just going to turn that off turn off the illuminates by default, and that's going to allow me to see exactly what's happening with this second area light. I'm going to turn the intensity up to 2, just so that it makes sense to me mathematically. And then I'm going to change the exposure. Now I remember that the exposure on the first one was somewhere around 10, so I'm going to jump up to 10 on this one, and this way I can see, exactly what this light is doing. Let me just exaggerate that a little bit. I'll go up to 12, and you can see I've got a real high specular highlight and then a nice rim light on there. I'm going to go ahead and turn on the original area light here. Now in this shader, we don't have any subsurface scattering whatsoever. And so let's turn the subsurface weight all the way up to 1. Now this is entirely a subsurface scatter solution. Obviously it's not what we're looking for. This is showing all of the subsurface and no diffuse whatsoever. Again, I can turn off the first area light, turn that off right there, and we can see exactly what the other area light is doing in terms of the subsurface scattering. And if I look at the area light number 2, and I can turn the diffuse down, and I can turn the specular already is down. So everything that we're seeing now is a subsurface scatter effect of this light. I want to take this head color. So let's just look at the inputs and outputs of the head color. And I want this also to be the subsurface scattering color, which is down here towards the bottom, the subsurface color here. So I'll take the out color and I'll map that to the subsurface color. And let's do a quick render here. You can see that I've got a subsurface scattering render here, and you can see that the light is coming in from the back of the ear there, which is giving me that kind of translucency. So let's take a look at what our parameters are here. We have the subsurface scattering color is specified by this color map, and it's the same color map that we've used on the diffuse, on the base. So let me just grab a screenshot here, and I'm going to take the base weight and I'm going to drop that down to 0, and I'll save a snapshot. And what this shows me is there's really no difference between a base weight of 0.8 and 0. And so what that tells me is that the subsurface scattering weight is what's being calculated first in this render. So if I change the weight of the diffuse back up to 0.8, and then I take the subsurface scattering weight and I drop that down to 0, now I'm going to see essentially what's a Lambert material on the face. So with a subsurface scattering weight of 0, then the surface quality of the face becomes 100% diffuse. So this is with the subsurface scattering weight of 0, and this is with it set to 1. So somewhere in there is my perfect balance, is what I'm looking for. So let's take the subsurface weight and bring that up to maybe a 0.8. So that's going to give me a 0.8 subsurface scattering, and then maybe a 0.2 of the diffuse, because they're going to be balanced there. And then finally, I want to take a look at the with the scale. I just want to look at the documentation that you were supposed to have read. And when I look at the scale, it says if the scene is in meters, then the scale can be set to 0.01, because a centimeter is equal to 1/100th of a meter. But in this case, the scene is in centimeters, So my scale can be set to 1, and it's a 1-to-1 ratio. So then my SS has radius for skin. Following the guidelines of the documentation, it's 0.37, 0.14, and 0.07. A little bit more on the red because we're going to see some blood through there. So let's just change the radius here to, it's an RGB. So let's change that to 0.37 red, 0.14 green, 0.07 blue. And that's going to give me a little bit more red in the subsurface because there's a little bit more blood just under the skin, you know, and so forth. So this is essentially what we're going to want to do. There is, you know, the roughness of the specular was determined by that map, which you can certainly change, and the subsurface weight is something that you can certainly change. There is a little bit of noise in here, so in order to compensate for that, or at least to identify that, I'm going to go into my AOVs and I'll look at a diffuse direct and indirect, and I'll look at a specular direct and indirect, and then down here I can look at my SSS direct and indirect, and I'll put those all in as my AOVs, and then I can go ahead and do another render. So it's 14 seconds, and then I'm going to look here. My diffuse direct has nothing there. Diffuse indirect has nothing. Specular direct. So it looks like everything I have here is in my subsurface scattering. I'm going to change that a little bit. I'm going to take my base weight and make that closer to, well, let's go all the way up to 1. Okay, and then my subsurface scattering weight, I'll make that 0.7. And that should give me a little bit better distribution. My radius, I want to make that a little bit more red. So I'll increase my red value a little bit, and I'll decrease my green value a little bit. It's going to give me a little bit more red in the subsurface scattering. This is looking a little bit nicer for me. So let's look at the direct diffuse. That is my diffuse there. It doesn't look like I have any sampling errors at all. My indirect diffuse is very, very little. Also very little sampling error. Specular direct, same. Specular indirect, nothing. Subsurface scattering direct. It looks like this is where I'm seeing a lot of my sampling errors. And let's look at the indirect. I have some sampling errors also in the indirect as well. So let's take a look at the Arnold settings. And my subsurface scattering settings are set to 2. I'm going to crank that up to 4. And my specular, I'm going to crank that up to 3. And I think that should be enough for this. So it increases the render time. It gives me a little bit nicer render. I see I've got, you know, my ear is a little bit more red here, and I've got a lot less noise in the render. So just to kind of accent what we're doing here, I'm going to take this first area light, and where I have my exposure set to 16, I'm going to go down to like 14. So I have less direct forward light, and you can really see what's happening with this subsurface scattering here. I'm going to go ahead and turn off this first area light. So all I see now is the subsurface scattering, and then whatever the effect of that backlight is. And I can adjust that backlight, as I said before, with the Arnold visibility section here under the area light 2. So if I don't want a lot of this diffuse illumination here, I can turn that down. And the same with the specular. So as it turns out, I wasn't really getting much of that from this light, but by adjusting these values, I can also adjust the effect of that light on the subsurface scatter. So let's just go ahead and turn this area light back on. And maybe increase the exposure. And this area light, I can increase that exposure as well. We know exactly what that's doing. It's giving me that backlight there. Now in this example, I didn't do anything with the eyebrows or the eyelashes. I'm going to leave that up to you. The jacket, I'm also going to leave that up to you. You have, you can create an Arnold shader for that, and you have multiple textures that you can put on that jacket, including a color and a normal map and a specular and so forth. So I'm going to leave that up to you as well.